Before starting, I would like first to describe, let's say, the roles that I have here. As said, I graduated in Iași. I was also part in the industry, part of the academia, and today I would like to give you a practitioner's view, so it's not an academic presentation by no means. I'm just telling you how I see it from the way I'm working with the technology on every day. And I'm here because, I don't know if you know, but there's a big, let's say, interest in Romania in the IT crowd. We call it the AI communities in Iași, in Cluj, in Bucharest. They are organizing a lot of events, and now there's a Romanian community called AI Romania. So if you see events that are organized by such people, please join. They're immensely interesting, and we managed to get together a lot of the researchers that we claim they left outside of the country. They join us, they give us presentations, and they describe how they are doing research in the top universities and top labs around the world. So without any further introduction, I will start. It's better seen on the monitors, but I'll just read it in English. So it's a famous saying by Paul Samuelson, was the first American that received the Nobel Prize in economics, and he said in 1966, I think, yeah, he said the following: Wall Street indices predicted 9 out of the last 5 recessions. And it gives us a very nice view that there are a lot of people doing forecasts and predictions. We call them doomsday forecasters. And many times they do it wrongly. And yeah, they are becoming more and more prevalent now because everyone talks about economical crisis again. And why is this important? Well, my presentation is structured as following. First, I will tell you a few words on why do I think trend detection is important, especially in the NLP context. I will describe how I worked with data from an industry perspective. So what were my challenges with respect to collection of data, data storage, and especially data processing. Then I will give you some examples, and I will show you why there's a difference between working with small data sets and large data sets, because I think there's quite a difference between the two. And I will cover a lot of the aspects that George has also presented previously, maybe from a slightly different angle. So I think everyone is really interested in knowledge. How can we extract knowledge from documents? And in my personal view, after discussing with a lot of people, let's say from the industry and potential clients, in the data analytics part, as George has described it, people are interested in knowing what is the trend in the last 5 years, what is the trend now, and what will happen with the economy, for instance, given, I don't know, in US troubles with elections and so on in the upcoming years. So detecting a trend and integrating this in a sense of extracting knowledge is, I think, immensely important, especially for NLP. Then in my previous experience by working at one of the Elsevier's main competitors, Digital Science, there was a lot of work in detecting major trends, for instance, I don't know, invention of the electric car and self-driving system, and small trends, for instance, inventing a molecule by a pharmaceutical company. Knowing that one of your competitors is about to use some really weird formula for a molecule ahead of time by looking at the research publications out of the major research labs is hugely important for their business development. Again, one of the important things in NLP knowledge discovery is the detection of events. So not only trends, but the tipping points. Something that triggers an economical crisis, like the Lehman Brothers failure or bankruptcy in 2007. And last but not least, the humans. I mean, we talk a lot about automatization, but in real life, we still need humans to validate, to check, to put their knowledge into the loop. Otherwise, whatever we develop is not feasible and not at the quality that we can expect. So I will say a few words about how can we extract data and collect data. George said previously that we have a lot of data currently available. I would challenge his claim and say we don't. I still think we need to be really careful on the way we extract the data, we collect data. I was part of the team of 4 to 5 engineers, and we were collecting data from 30, I think, sources all around the globe, all on different meridians, all with different sites, all with different content, organization, let's say, structures, and it was a huge challenge because their sources was changing the information almost monthly. So we had to collect the data, we had to go around a lot of the captcha systems that they have in place, the protection, we had to store the data and make sure that it's always up to date. That's not trivial. It takes a lot of human effort and costs a lot of money. And of course, if we want to use a data set that was used in famous research publications, we can do that. But if we want very, very specific data, then we need to put a lot of effort in this. Then there are a lot of legal issues. When I started working in an industry in NLP projects, I thought that we can just download data from whatever website we can find. And that was a big no-no. First, we have to make sure that we gather the data in a fair way, as in we don't destroy the resources that they have available on their website. We have to make sure that we pay for the data. Otherwise, we will get lawsuits from them. And even more interesting is that we cannot use data collected from a source to develop a project from another client, because they can have contractual limitations by saying, no, you are allowed to use this data, but don't use it for other clients. And I've seen such restrictions. And the easy way to go around it was to develop really intricate algorithms and models in binary form, when nobody knows what's behind it, and then reuse that knowledge from one client to the next. That was a trick, let's say. I'm not sure how legal was this, but it was a trick that we used. And also GDPR. I mean, a lot of people talk about GDPR nowadays, but GDPR means that we have to store data and then delete data when the client asks for that. And we have to prove that whatever data we've got, we have deleted it 100%. Otherwise, we can lose a lot of money. So these are, let's say, things that are not technical, relate to the law, relate to the, let's say, the society is organized, but when we work with NLP, we have to be aware of this. Data is expensive, and we have a lot of legal restrictions in using it. So let me say a few words about what are the desired qualities of the data, and based on my experience. If we talk about historical data, we have to make sure that there are no big gaps in the data. We don't miss, for instance, information around the economic crisis of 2008 if we want to make an educated guess about the upcoming crisis. Because if we don't use that knowledge around that specific event, our techniques will be faulty. Then we have to have high granularity. If we collect data once every 6 months about a certain type of data, for instance, clinical trials and pharmaceuticals, we will lose a lot of information. We will lose a lot of knowledge that is invented almost every day. Then the data has to be relevant for the topic. We cannot make educated guesses about financial crisis if we only collect data about, I don't know, agriculture. I mean, they could give us some hints, but it's not specific to the event that we want to make educated guesses about. Then, of course, last but not least, is reliable sources. Of course, there's a lot of information available on the internet, but not all the data comes from reliable sources. I mean, we can have a lot of debates about what's reliable or not, but it's important to make sure that the data we've got is not biased. It doesn't come from sources that are not reliable, and yeah, it's readily available when we want it. The last point on this slide is I want to tell you, let's say, with bold, good data costs a lot of money. And that's no, let's say, I'm saying something that everyone knows, but based on my experience, collecting information, cleaning information, storing that information is actually very, very expensive, and partially explains why the startups in NLP have a difficulty in being successful. With respect to storage and processing of information, when we collect a lot of information, for instance, I was working on a project where we had access to 100 million documents, publications. Having access to this amount of data fast from 3 or 4 data pipelines in parallel is not trivial. It requires cloud infrastructure that can cope with such loads, and that's not always available for a small company or for a research lab. So then we have to use cloud platforms like Amazon, Google, and so on, that provide such solutions at hand. Then, of course, security and making sure that the data is not lost is also important. One of the things that I was not aware when I started working in NLP projects was related to the scalability of the pipelines, so the processing pipelines. I mean, we can process 100 documents at once, or 100,000 documents at once with a small laptop, but when we talk about millions or hundreds of millions of documents, we have to make sure that the data processing pipelines can scale. And when I mean scale, I mean cluster Amazon size scalability. Hundreds of machines, huge amounts of data, huge amounts of memory, and so on. And that's probably also that explains why let's say in Romania, startups have a difficulty in doing projects that are, let's say, Google-like or Google scale. We need a lot of infrastructure for processing large amounts of data. And the engineering effort sometimes is much larger than the scientific/algorithmic effort. And I draw a graph based on my view on how I see it. So a lot of people start an NLP project by putting a lot of algorithmic effort into it. And you see with the green graph on the slide. And initially, the engineering effort is not so much important. Then, if the amount of data starts scaling, the engineering effort becomes much more prevalent, to the point that it's actually more important than the algorithms that we use. That's let's say, 90–80% of the projects have to have a mix between engineering skills to build a huge processing pipeline somewhere in the cloud of Amazon, but also have algorithmic knowledge. When the data is huge, absolutely huge, then the algorithm knowledge has also to come in place to overcome some of the limitations that we have with the 100% engineering approaches. And that's why you see, for instance, at Google, at Amazon, in their research labs, masters of programming, but also they're really good at algorithms, because they have to optimize to the last bit the infrastructure that they have. So then you see to the right side of the graph, there's a lot of engineering effort, but also the algorithmic effort is hugely important. I would like to give you an example of why working with small data sets is different than working with huge data sets. A lot of people think that just by dumping the first algorithm, NLP algorithm that they can find on the internet, let's say in terms of popularity, would solve any sort of problem. But the trouble is most of the data sets are actually small. I mean, not everyone is Google, not everyone is Digital Science, for instance, the company that I worked on. A lot of the data that we have is small. So we need to be really careful on the types of algorithms that we use. For instance, on the graph, I took a BBC data set with news labeled by the reporters and displayed on their website in 2005, I think. And I just wanted to see which algorithm performs better than the other. And it turned out that, for instance, naive Bayes, because the Bayesian statistics has a fast convergence rate compared to other methods, was actually more suitable for small data sets. So having a bit of knowledge with respect to the algorithms really helps projects also in an industrial setup. So not jumping directly on the most popular methods is actually a good approach. We should test, we should validate which approach is better for the task at hand. In the project that I'm working right now, we are building a data processing pipeline for NLP. It's a classic pipeline. We want to detect trends in news items all over the world, and we do the classic steps of pre-processing, tokenization, lemmatization, and so on. And in the end, we do the actual trend detection and classification. George said earlier that maybe such an approach is not the popular one nowadays, because neural networks are taking over the world, let's say. That's absolutely true, and I confirm it. But not having, let's say, a comparison with the classic approach is also detrimental. So we need to make sure that we compare the state of the art, the classic approaches, with what will happen with respect to neural networks. It's very easy to just install TensorFlow, put the data set as input, and then you get something at the end. The problem with neural networks, as far as I see it from the practitioner's point of view, is that it's a black box. We don't know why it behaves so well. When does it behave well? If some manager asks me, or a client asks me, why do you see a trend in an increasing chance of having an economical crisis? I have absolutely no clue in answering this question. I have a better clue if I use a more classical approach. If I use statistics, if I use a Bayesian approach, and so on. And explainability is crucial, also in a commercial environment. So there are clients, potential clients, that are more interested in having 80% accuracy of forecasts, but knowing why that 80% is there, than having a 95% accuracy forecast and not being able to explain why. And it's something that I wanted to mention, because it also comes from an industrial requirement, having explainability of the machine learning algorithms. The second example that I wanted to give you, and it's better shown, I think, on the monitors, we are working on something called rare event detection. Economical crises are, we call them rare events because they happen roughly between 7 to 10 years. And it affects everyone, including the research world. And we wanted to see, can we have an educated guess based on NLP techniques when the next economical crisis will come and why? So this is by no means an academic, economical approach to this problem. I wanted to see if we can guess this by using NLP techniques. So we built up a corpus of 15,000 news items in the last 30 days. And we know, we have a guess that there's a high chance the economical crisis will be triggered maybe by something happening in the Far East, China, US-China relations, and so on. So we wanted to see if we select from the news items all the mentionings, and based on their importance, about US-China relations and the financial crisis items, do they correlate? Of course, I will not enter a discussion about correlation and causation. That's a topic for a conference, I think. But what you can see on the graph is that there is a pretty good correlation between US-China relations and the mentioning of financial crisis. So if somebody asks me, what can you say, let's say, from an NLP perspective about the financial crisis? And I will say there's a high correlation with what's happening in Far East, for sure. And unfortunately, the resolution is quite low. But I just plotted the correlation coefficient between financial crisis, mentioning about financial crisis, and news items about USA. So you see on the leftmost bar is the correlation with US news, and the second most correlated news item is US-China relations. So whatever happens in the commercial war between these two mega powers will influence the upcoming financial crisis, based on my experience. That doesn't mean that they are caused by each other, but they do correlate quite well. So I would like to conclude now. First of all, I would like to say that trend detection is very important nowadays for doing forecasting based on NLP techniques. Data collection, data engineering are non-trivial, depending on the size of the data sets and the effort that we put in collecting the data. We need to pay attention to the cost and the effort that we need to put in collecting the data and doing all the engineering work. Having different approaches for small data sets and large data sets, I think is important, because not all the algorithms are the same, and they don't converge all the time in the same way for small and large data sets. So we need to really test and be careful on how we use the tools that we have and the algorithms that we have. And yeah, I would be happy to answer questions.
Thank you for the interesting presentation. In fact, I liked the discussion about neural networks, the advantages, and that you said that were black boxes. I think it's discussed. Okay, so we have time, I think, for one or two questions, please.
It's not actually a question, just to emphasize from a specific project what we have said. Not earlier than yesterday evening, we have had a discussion in our group in the Reteron project in the workshop that is joined with this conference. Try to find ways to gather speech data, also annotated with text, so paired is transcription. And we find out how difficult this is. And we had also a very interesting experience by building the Corolla corpus, which is the large corpus of Romanian contemporary language, and discussion with different data providers, textual data providers from all over the country was not at all easy. So collecting data in NLP is a thing that we all face every day if we want to train our models on real data. Thank you.
Yeah, so just a comment as well on this. Last week I discussed with a company based in Ireland, and they asked for access to news items from all around the world. The minimum cost was 30,000 euros per month. So these are the figures that...
Well, I've seen somewhere an estimation of the quantity of time invested by data analysts in preparing their work. So it was something like 80% of the time they spend in curating data, cleaning, selecting, classifying, and so on. So this is not something that is very interesting for academia. On the other hand, I think that the GDPR and uncertainty, legal uncertainty, at least in Romania, what is legal and what is illegal, what dangers hanging over you as a data collector might hamper you. So I think that it is absolutely necessary to have a legal initiative here, something like fair use of data in the United States, because as Dan mentioned, we had a lot of discussion, long discussions about data we will deliver officially at the end of the project. It has been collected a lot of data, but the status the legal status of it, it is not clear at all. So this is something that it's going out as a cry from the academic.
Yeah, I think it's a gray area. What I've seen, a lot of research groups, I've seen one in Sweden, they have freeware accounts from major, let's say, organizations in US that they provide data sets to them. And they have to mention the fact that they used the data sets from that specific company. The company gets a lot of, let's say, publicity. And then the research community can do their research without having to spend that 80% of the time to collect the data. And unfortunately, we don't have in Romania entities that collect such information and they put it into the open. I'm sure there are, but they don't want people to use it in the open. Partially because there's no commercial viability in doing this. There are no, it costs a lot of money to collect that information, and there's no legal framework, as 100% true, that can sustain such an approach. Because as far as I know, newspapers have to give snippets of news of 300 characters max, and that applies to everything, including academic research. So we cannot do NLP research with news items of 300 characters. We need to have full body texts with a lot of history and so on. So 100% confirm that that's an issue.
So it was very interesting. Both of presentations were very interesting for me. I am coming from academic research. Adriana Vlad is my name. But I was a little bit, no, I enjoyed a little bit. You encourage us more than the first presentation. In a way, maybe if I correctly understood or not, I am not sure, but I had the impression that you made a difference between data collection and data use, because in data use, it's the scientific use of data, not legal or not. It means you said in a way, pay attention. As this pay attention, it's a lot of knowledge from the scientific point of view, because there are, if we mean not black boxes, but if we mean, for example, statistical methods. Data use means a lot of care and knowledge. And I do not know if that is included in general data collection or not. Generally not. It's a different thing. And sometimes we don't care so much what is legal or not, because we don't sell, we are not vendors of product. But maybe we have to pay attention of that. But our main attention was to do something we can control, we can understand from scientific point of view. I do not know if industry is interested of this kind of work we did. Or I am not so sure if they are. For example, I think that China pay more attention, and I could see when we have a research and a scientific publication, they immediately had a look on, and they are writing us separately. But here, and this is one thing, and another thing is, maybe don't take that in a wrong way. I am not sure, both of you in a way represent Romania too, but you are asking, you are founding that we don't exist in a way, from industrial point of view, from this point of view. But you, for example, you are representing Romanian or not? For example, because this is finally this is a political thing. All our people or people who are studying here and very good studies and very well formed for research are no more here. Then you and you and you are representing us. No, just thank you.
Okay, thank you. You have something to...
Yeah, so without going into politics, it's not my favorite subject. First, I would like to say, again, based on my experience on collecting data, collecting data is very expensive. It costs a lot of money to buy data. So, as I mentioned previously, the cheapest source provider of news items was around 30,000 euros. There is also businesses that only do that. They collect data and they sell it as such, maybe carefully polished, and then you just use it, whatever you want to build. What they are trying to do, and I think in 2016, the best startup in Europe was a data collection provider of information. They are based in Estonia, no, not Estonia, in somewhere in the former Yugoslavia region, and they are immensely successful. So they sell information, they collect data and they sell it. In English, in Russian, in Arabic, German, French, and so on. So there is a business of collecting and selling information, and that's it. Then there are also businesses that get that information, like I want to create my project now, that gets the information and then creates value-added products on top. Those providers of data, they always want to add more services because they want to sell more expensive, let's say, products to the market. So there's a fight between people like me that doesn't want to spend that 80% of the time collecting data, just like you, and those that collect the data and have to manage legal issues and so on. And we have to be, let's say, aware of how the ecosystem of companies and research is working. Otherwise, whatever we do will have legal issues, let's say, troubles with using that information. How can I publish a paper if I'm not allowed to say from where I get the data from? How can I 100% know that the data is not biased? And if we are talking about Romania or European laws, whatever we do here has to comply with the European regulations. And there are a lot of restrictions, GDPR, we have to publish our sources, we have to say when and how we collected that data. So these are not trivial aspects and doesn't come by to Romanian politics. If we are translating this conference to Lithuania, it will be the same discussion. So it's not about Romanian politics, it's about ethics in academia, let's say.
Okay, thank you. Thank you for both presentation and for this very interesting session. So I think now we have a